Hello everyone and welcome to today's online class for class 12.
Carbonyl test is used for the identification of primary amine. When a primary amine NH2 is treated with CHCl3 in KOH medium, it produces RNC, alkyl cyanide, and very unpleasant 3KCl and 3H2O. This RNC that produces a very unpleasant smell. From this unpleasant smell, we can identify the product to be a primary amine. Lieberman nitrogen test is used for the identification of 2-degree amine. This is a 2-degree amine. When it is treated with NaNO2 dilute HCl, which is nothing but HNO2, it produces R2 NO, N-nitrosamine compound. This compound is oily, yellowish oily in nature. From the formation of this yellowish oily N-nitroso compound, we identified the initial amine to be 2-degree amine. Aromatic amine is this compound. This compound is known as aniline. When nitrobenzene is treated with NaCl, it produces aniline. Another preparative method can be used as when this compound, which is known as benzamide, is treated with Br2KOH, it produces NH2 on the benzene ring. Amine ring, this is benzamide. When treated with Br2KOH, produces aniline. This method is known as Hofmann degradation reaction. These two are very well-known methods for the preparation of aromatic amine or aniline. Aniline undergoes protein resonance like this one. From these resonating structures of aniline, we can obviously observe that the two ortho position and one para position contains negative charge, which by default increases the electron charge density on the two ortho and para position more compared to the meta position. As a result, when an electrophile attacked the aniline to produce a compound, it preferentially attacked ortho to ortho position and para position. As a result, aniline become ortho-para oriented with respect to electrophile. Not only that, aniline is so reactive that instead of producing mixture of ortho-para product, when electrophile attacks, two ortho and one para position simultaneously gets occupied, and the three positions at the instant occupied to form the product. The first reaction of aniline that we are going to do is the bromination. We know that aniline is ortho-para oriented, so when bromination is done, as aniline is extremely reactive, all the three positions, two ortho and one para, will be occupied by the bromine and this product will be formed. Now, the reactivity of aniline can be reduced by this method. This group is also ortho-para oriented but less reactive compared to aniline. That's why now if the bromination is done, as this is a bulky group, predominantly para bromine will be formed. Now, the usefulness of this group is that incorporation of this group is very easy and the removal of this group is also very easy. Just by doing hydrolysis, this group will be revert back to amine group, and thus para-bromoamine can easily be formed. Now, to form ortho-bromoamine, we need to block this para position, and that can be done by incorporating H2SO4. Now, by incorporating SO3H group in the para position, as this is a bulky group, we try to occupy the para position in a preferential amount. And now, if the acetylation on this NH2 group is done, this will be formed. And now if the bromination is done, as the para position is blocked, it will incorporate in the ortho position. Now, when the hydrolysis will be done, both these groups will be removed, revert back to the NH2 group, producing aniline with a bromine atom on the ortho position, that is ortho-bromoaniline will be produced. Now we are going to study how nitro group is incorporated in the aniline. This is aniline. At first, acetylation will be done to reduce the activity. NaCO CH3 group is incorporated. Now, when nitrogen mixture is given to it, as this is a bulky group, preferential para nitro incorporation will be done, and after the hydrolysis at the last step, we can prepare para-nitroamine. To produce orthonitrile, we need to use the blocking method. Aniline at first sulfonated at para position, then acetylate with the help of CH2COCl, and this group will be transformed to reduce the reactivity of aniline. As the para position is blocked in this group, so when we will do nitration, the ortho position will be incorporated by NO2 group. At the end, the acidic hydrolysis will revert back to the aniline compound with an ortho-nitro substitution. So this is how ortho-nitro substituted aniline can be produced. Now there is another way to produce meta-substituted nitro group also. We have already studied how to produce meta-dinitro benzene. By treating meta-dinitro benzene with this compound in ethanolic medium, we can convert one of the nitro group as NH2, which will lead to the meta-nitro aniline. Now the next reaction of aniline is very important. When aniline is treated with NaNO2, dilute HCl at 0 degree to 5 degree Celsius temperature, benzene diazomium salt is produced. Now this benzene diazomium salt is extremely useful compound. It can be used for the preparation of many other compounds like benzene diazomium salt is to react with CuCl, HCl, chlorobenzene is formed. When CuBr, HBr is treated, bromobenzene is formed. When HBF4 is treated, followed by hydrolysis, followed by heating, fluorobenzene is formed. When Ki is treated with this benzene diazomium salt, iodobenzene is formed. When CuCl, KCl, CuCl, HCl is treated with this benzene diazomium salt, benzene cyanide is formed. When this benzene cyanide hydrolysis, benzoic acid is formed. When it is treated with H3PO3 or ethanol and heated, this entire group is removed and benzene is formed. When benzene diazomium salt is hydrolyzed, phenol is formed. When benzene diazoxide salt is treated with HbF4 followed by CuNO2, NaNO2 and copper dust is added to it and heated, nitrobenzene is formed. So, we have studied the formation of nitrobenzene amine from nitrobenzene, and from amine via the formation of benzene diazoxide salt we can also form nitrobenzene. Now this is the usefulness of this benzene diazoxide salt, because lots of important aromatic compound can be formed via this method. That's why this is a very important preparation of reaction of amine. Aniline is identified with the help of azodine test. When aniline is treated with NaNO2 dilute HCl at 0 degree to 5 degree Celsius temperature, benzene diazoxide salt is produced. When this benzene diazoxide salt is treated with beta naphthol in NaOH solution, this azodine is formed, which is red in color. This red color azodine formation proves that the initial product that we had taken is